Hey guys, how are you? I'm here to talk to you through integration. Now, if you look on the left of the screen here, what you'll see is the rules of integration. We haven't really touched on those yet. I did want you to read through them in your book, but I just want to quickly explain what each of them are. Let's look at some examples and then we'll go through the actual, some shortcuts for you to find integration. So if we look at this first one here that just basically says the integral of the bound integral from a to a of f of x of dx equals 0. That's basically saying that if I have a graph, okay, so if I have a graph and I have a function of my graph and I want to go from A to A, that's just going to be a straight line, okay? And the area of that straight line is going to equal zero. Okay, fairly self-explanatory. This one here, where we've got the area of B to A of C of D of X is equal to C times B of A, well, that's not a difficult one to look at. If you think of it, obviously I've got B, A, and I've got a constant in respect to X. When I differentiate that, I'm going to get C lots of X, okay? And it's going to be between B and A. So that's going to equal, in this case here, CB minus CA. Take a common factor C out, and it's going to be CB minus A, okay? Again, not too difficult. Part 3 we went through, it's basically saying again, if I have a graph, okay, and I want to go from A to C and I've got B in here, then basically I can break it up if I want to. If I want to go all the way from here to here, I can actually do it in two parts. I could go from A to B if I wanted to, and then I could go from B to C, and that would give me my total area. Okay, again, not too difficult to do. All right, the fourth one that we look at is just basically saying that if I have an area, okay, and so my area might look like that, and I go from A to B for this area, and I get a positive area. If I go this way, it's positive. If I try and find the area back this way, it's going to be negative, okay? It's pretty self-explanatory, sort of like movement. If I move in the positive direction, that's in the negative direction. So what I'm looking at is I can actually flip things, and this becomes important when I get graphs that look like that, where I'm going to have an area here and an area here. I actually use a combination of Rule 3 and Rule 4 in order to work this out, because I've got here A, obviously B and C. So if I want to work out from A to C, I'm going to have to go through B, but I'm going to have to go A to B minus B to C, because that will be a negative area, in order to get my total positive area. Alright, the last two are really important and you'll use them a fair bit. It's basically saying that if I have a constant, here, then I can just put it out the front, okay? And it's not going to get involved, and it's like factorization, okay? And we can do that, all right? Last but not least, this last one is a really important one. It's basically saying that if I have two functions, so I have the integral, and I'll say, let's say 2x squared plus x, okay? If I have that there with dx, I can actually split that to the integral of 2x squared dx plus the integral of x on its own, okay? So then these become two singular functions, okay, or two singular integral functions, and you should be able to work it out, no problems, okay? So in this case here, just running through that one quickly, that would be 2 on 3 x cubed plus c plus a half x squared plus c. Now because I've got a constant and a constant, it's still going to be a constant, so this will be 2 on thirds x cubed plus a half x squared plus c. Okay, so these are the rules and they're really important to know them. You're going to use them a fair bit, so if I were you, I would learn them, but the ones you're probably going to use the most, I would say, are this one, this one, this one, and this one. So the last four are really important to know because they are the rules that you will use the most through integration, okay? So let's have a look at a couple of examples here. So I've got here, if y equals x to the 7, find dy and dx, and hence find x to the 6 dx, okay? So basically a lot of the times here when starting off integration, they're going to get you to integrate this first one and see how it's different to this second one, because we know we can go backwards. So if I've got y equals x to the 7, okay, and I was to go dy on dx, or find the derivative of it, I'm going to get 7x to the 6 here, okay? If I was to integrate that back, okay, that's what I would get up there. So how is 7x to the 6 different to x to the 6? So, well, let's look at it this way. If I wanted to make it go backwards, all right, it's my 1 divided by n trick. So how is this different, all right? So if I was to turn around and say, all right, the integral of 7x to the 6, we know that would equal x to the 7, okay, plus your constant. So how can I make x to the 6 the same as that? So if I'm looking at integrating x to the 6, well, I can times it by 7 here, okay, which makes it the same there. But if I times by 7, I'm going to have to put 1 on 7 out the front here, okay, to make sure that I haven't changed my figure. So I know that this here is equal to x to the 7. So it's going to equal 1 on 7 times x to the 7 plus c, which is what we've just done there, which is just going to equal 1 on 7 x to the 7 plus c. Now I don't have to put a 7th c because the 7th is a constant, and timing a constant by a constant is still going to be a constant. So that's how we would do that one just there, okay? That's a really easy one that we're looking at right now. So we'll look at part B and we'll make our way. Again, we'll have a look at it. So, okay, the way you could look at it are two ways. You can do this graph way if you want to and work backwards, or you can just find your integral like this way with the substitution and go forward. So let's look at the next one now. The next one, part 2, which says if y equals x cubed, I'll just get my pen up. It's saying if y equals x cubed plus x squared, find dy and dx. So I've got here, and I might look at it both ways here. So x cubed plus x squared. If I was going to go dy on dx, that would be equal to 3x squared plus 2x, wouldn't it? Okay, so when I go backwards this way, I know that's my integral. So how is 3x squared plus 2x different there? Well, it's not. So I know that going backwards, it's going to be the same. So the integral of 3x squared plus 2x will be x cubed plus x squared plus c in this case here. Okay. Last but not least, we're going to start looking at you're going to look at logs and exponentials in this case here, and we're going to have e to the 2x plus 1, and hence integrate it. Well, again, let's see what we can do here. I'm going to use a different color because I'm all over the shop with the black. So let me just fix this up a little bit for you so it follows a logical sequence, which I'd like you guys to do. So I'll put that back over there. We do know, again, this is part A. Okay, that's part B. Let's look at part C now. So if I have e to the 2x, or 2x plus 1, okay, and I was to integrate that, I would get 2e to the 2x plus 1, okay? So they want me to integrate. If I was to integrate that backwards, I would get e to the 2x plus 1. But what they want me to integrate here is itself, e to the 2x plus 1. So they're saying integrate e to the 2x plus 1, okay, with respect to x. A question again, how is this one here, how is that one there different up there? Well, there's a factor of 2 out the front, so I might just change colour here so you can actually see it for yourself. Okay, we might just change colour. So if I was to integrate this, I'd have a half times 2, because a half times 2 is 1. Alright, and then we'd go again back to e to the 2x plus 1, okay, dot dx. now I can see that e to the 2e to the 2x plus 1 integrates back to e to the 2x plus 1. And so I can work this out. So this is a half e to the 2x plus 1, okay, plus c. And now when I times that out, I'm going to get a half e to the 2x plus 1 plus c. Again, I didn't worry about timing the c by a half because it's a constant, okay? And a constant times a constant is still going to be a constant. So that's how we work out stuff like that, okay? Again, it's not too hard. Just do the derivative of the one they ask you to and find out how its derivative is different to what they want you to integrate to, and just put a factor in there. Make sure you cancel out by putting its inverse out the front, okay? What I have done for you though is I've gone into the textbook and I've gotten out basically the functions and their integrals for you, so you can put this on a cheat sheet, really important, okay? But what I've also done is I've also added a few more here that you might find really, really interesting, okay? So like before there where we had find the integral of e to the 2x plus 1, we did the dy and dx and then work backwards. You can actually apply this rule here. So if I have my function of e to the ax plus b, which is that's what it is there with respect to x, then what it is, the derivative, or not the derivative, the integral is equal to 1 on a, which in this case is 2, okay, times by my original function, 2x plus 1 plus c. So that gives you a huge advantage and a huge shortcut compared to what we did before, which was find the derivative of 1 by itself and then work out to go back with the integral. So what I've done here is I've put these rules in here for you to use, okay? By all means, when you do the work in the textbook, use these rules, okay? But understand how you use them, okay? So really try when they ask you to work antiderivative, we go back and we do it this way, okay? But as we get further and further into the book, when it becomes harder and harder, it should start becoming second knowledge. I want you to start using these rules here, okay? So really now this should get you through pretty much. If we have a look at the textbook, sorry, I've lost it. But if we have a look at the textbook, this is basically 6E, 6E1, stuff like that. So here, as I said, 6E1, the example we took from the first three here. So you should be able to do this no problems now. Okay, and you should be able to move on now to the simple integration stuff such as 6E2 and stuff like that. So have a crack at it, guys. If you are having problems, please, by all means, catch up with me. More than happy to answer any questions for you, but just some hints for young players. I'd really make sure I have this noted down, okay? And again, I'd make sure that I understand what these rules are here, okay? So get those out of your textbook and especially understand these four here, okay? Apart from that, I'll see you later and enjoy.